In this video, we're going to look at the 7805 component. And what it is, it's a voltage regulator. It takes a higher voltage in and outputs a lower voltage. The lower voltage is fixed. It's fixed at 5 volts. And so there's a number of different 78 integrated circuits, these 3-terminal integrated circuits. And the number where these X's are tells you the voltage. So there's also 7812, 7806, and so on. So that's 05. It's going to output 5 volts. You need to have probably 2 volts higher than that coming in. And so we want the power supply at least 7 volts. But we can go higher. This 7805, when I looked at the data sheet, can go up to 35 volts. So you can put 35 volts across here, and 5 volts is going to come out. So it has this metal tab here that helps it cool off. So you can put a lot more power, have it dissipate a lot more power than the TO92 package transistor. You can also attach a heat sink to it. That also helps it cool down and let it pass more current. The bigger the voltage difference in than out, the hotter it's going to get for a given current. Luckily, if it gets starts getting too hot, it starts shutting down. It starts limiting the current so that it can stay cool. And so if you notice the voltage dropped, that's because it's limiting current. That means it's probably getting too warm. You need a bigger heat sink or whatnot. So in any case, we have a couple capacitors here. And with this power supply, I definitely need the capacitor on the input side. I believe with the 9-volt battery, I did not have any problems with using this directly. But we're not getting 5 volts out if I don't have that capacitor. I'm using a 0.1 microfarad capacitor on both sides, just because I already had them on the board. But in any case, let's quickly look at the pin layout here. Left pin is input, middle pin is ground, and right pin is the output. So I'm going to turn it this way. Now the output's on top, input's at the bottom. And we will go over to the board over here. And let's pluck these capacitors. As I said before, they're both 0.1 microfarad. But we'll just do this so we can see it go into the board a little easier. So in is at the bottom, ground is in the middle, and then out is on top. So ground is still negative rail, and in is going to the positive rail. So there's also a 7900 series, by the way, if you want the voltage more negative than ground. But we're not going to worry about that. I have those in my kit. So we got in there. Out on top, I have a resistor and an LED. So first, let's look at without the capacitor. Because as I said before, I was pretty sure I was able to get 5 volts without the capacitor if I used, we'll look at this, that we got 7 coming in, if I used a battery. So this is switching. It's using switching to adjust the voltage out, and so it's not a steady voltage. And so some components, they have a problem with that. So we will first look, we have to hit the power button so the output goes on. We'll first look at the voltage at the rail. I can just go to 2 points and look at that. We'll see we got 7 volts. And just a speck shy. Now we'll go across the resistor, the LED, and now you can see it is 4.3. Also, you notice that the current dropped from the power supply. So I think it's actually 5 volts right now, but for some reason the multimeter messes it up, which is really interesting. So I'm just going to add a resistor from ground to the input. That's a 0.1. These get very hot, by the way, so if you got more current going through them, don't touch them. This is only 16 milliamps, not very much. So now let's see what happens with the voltage. If we go across it, there you can see just a speck below 5 volts. We're doing pretty good. Now, we could also add the other resistor from ground to the output, as we saw before, but doesn't look critical now. So I'm just going to go, you can see the LED is not getting brighter. This is a 220 ohm resistor. You can see current went up a speck, but a little more current's probably going through the component more than the load. So I'm going to go all the way to 30 volts. That's as high as this goes. this power supply. There we go, 30 volts. Now, that obviously didn't burn out because we don't even have 20 milliamps of current coming out of the power supply. So that's a nice thing about that power supply. You can keep an eye on the current, get an idea of what's going on. And there you can see that we still got 5 volts across there. So the voltage can go way up. And I believe you could see that, but just in case, I'll show that a little bit better. We got 17 milliamps of current. So that's it. It just outputs. It's for, you know, smaller loads and stuff. But you can output about 1.5 amps maximum. You probably need a really big heat sink and maybe some other cooling system. Fans being blown on metal really help to cool them down. So you may need like a fan and a heat sink or something. But in case, that's all topics for other videos. And I'm going to end this one right here. Pretty straightforward. The voltage in can vary, but the voltage out will be steady as long as you got at least 2 volts above the voltage out, whatever that is, because as I said, not all of these are 5 volts. Some of them are 12 volts and a bunch of other voltages. So in any case, check out one of the other videos that I'm posting. Make sure you click like, subscribe, and the bell. Donate to Patreon if you can. That would really help a lot. I'll see you in the next video.